Good morning. So today is math lesson 148. We're going to use page 267 and 268 in your workbooks. Sorry, I'm grabbing my stuff here. And we're going to start off with some mental math to refresh our memories, get our brains in gear, wake us up a little bit. We're going to have 4 problems today. So here we go. 18 divided by 3 times 6 plus 4 minus 7 plus 8 plus 1 divided by 7 equals. Hopefully you got 6 when you follow that train through, okay? This is not order of operations, it's just right in order as I give it. Next one, 3 times 8 plus 2 divided by 4 times 7 plus 3 equals. Did you get 55? Because that was the answer. Next one, 5 times 8 plus 3 minus 2 plus 8 divided by 7 times 8 plus 1 equals 57 is the correct answer, so I hope you had that. Last one for today, 6 times 7 minus 3 plus 1 minus 6 divided by 7 times 6 equals. If you have 24, you had the correct answer. So hopefully you were able to keep up and at least got close, even if you got tripped up. All right, going over some of these with our measurements and review again. This is one we don't use often, but a square mile is 640 acres. Okay, so it's not square acres. Acres is a unit that is already measured in square format. So 1 square mile is 640 acres, and we had to use that, I believe, from the back of our book in a problem earlier during this homebound session. All right, here's another one we don't use as often. 1 acre, when you're talking about square feet, is going to be 43,560 square feet. So we don't use these very often, but they do come up. It is in the back of the book if you need to reference it. But if you see them, there's the information for those of you that like to memorize and know it all the time. All right, square mile is 640 acres. And then this one, that's a longer number, 43,560 square feet in 1 acre. All right, the rest of these you should know. 9, remember, because it's 3 feet per yard, so 3 times 3 is squaring it for a square yard. 144, right, because there's 12 inches in a foot, so square it. 12 times 12, we get 144. Okay, do you recognize this formula? Hopefully you said area of a square. This is the formula for area of a square. You could also do s to the 2nd power. Okay, but side times side gives us that. How about this formula? If you said rectangle, you've got it correct. Perimeter of a square. How about this one? Perimeter of a rectangle. Double the length plus double the width. And of course, we learned how to write these without that multiplication sign. All right, let's go through the rest of these a little more quickly. Diagonal, vertex, octagon. This one should be instantly recognizable. If you have to count, there's 7 sides, heptagon. Hexagon should usually be recognizable. Pentagon. Trapezoid, only 2 parallel lines. Rhombus. Square. Rectangle. Parallelogram. This isn't asking for a hexagon, it's just recognizing that it is a polygon. It's a simple closed figure made up of straight lines, no curves. Okay. What do we call triangles or any shapes that are the same size and same shape? Congruent. What if they're the same shape but not the same size? Similar is what we're looking for. Okay. Parallel lines. Perpendicular lines, remember they form 4 corners perfectly. Intersecting lines, they can cross in any way. Angle, ray, line, line segment, and point. Okay. All right, before we get to today's lesson, let's review two-step equations that we did yesterday. Remember our goal? Get the variable alone. When we do that, we always look for the side that's not next to the variable. There's nothing to do here. So now we move to this side and we remember that these two are attached, just like the baby. Okay, it's still attached to the mama. Eventually it will leave the house, but we get rid of the older one first. So the one that's not connected, we're going to move. How do we do that? Well, we do it by undoing it. Let's see how well I write upside down. Oh, that's lovely. So that this is gone. Oh, that's interesting too. But we keep it balanced. We keep it equal on both sides. Maybe this way will work better for me. So we still have 3 and x together. Okay, the baby did not leave the home yet. All right, nothing's here. Now on this side, we have a 3. How are we going to get the variable alone? Because we're still not there. We only did one step, and it's a two-step equation. How do I separate these? If you remember that it's multiplying, then you should remember also that we get rid of that or undo it by dividing. Of course, I have to do the same on both sides to keep it equal. Now this is gone. X is happy. It's all alone now. It's a much quieter house. All right, 3 divided by 3 is 1. And of course, we can check it by putting it back into the equation. 3 times 1 is 3. 3 plus 7 is 10. 10 does equal 10. So we know that 1 is the correct value. All right. If you have your math sheets with you, go ahead and follow along with me as we go over temperature today. It's not necessarily what we're going over as reading thermometers. You've done that since way back in elementary grades. But what we are going to cover is how to convert from one system of temperature, let's say today we're doing Celsius, and converting it to Fahrenheit. Tomorrow we'll learn the reverse. All right, so looking at the facts, we've got one, a thermometer. I know you know what this is, but its definition is it's an instrument used to measure temperature, how hot or cold something is. We know this. Fact 2, the degree symbol is that little circle, and if you notice, whenever we write it, it's very clearly a degree sign. It's not even close to looking like an O, but that's the symbol to write degrees, and that's what we measure temperature in. Fact 3, Celsius and Fahrenheit are the two temperature scales. Fahrenheit is most often used in the United States, although Celsius, which is the metric measurement. So when we were talking about milli, kilo, centi, deci, all of those as metric units for capacity or mass or distance, Celsius is the metric measurement for temperature. Now it's usually used in the scientific field. So when they're talking about scientific experiments or anything medical, they often use Celsius, okay? But when we're in the hospital and they tell us our temperature, because we're in the US, they tell us it in the Fahrenheit scale, okay? For every 100 degrees Celsius increase, there's a 180 degrees Fahrenheit increase. Therefore, 1 degree Celsius measures a greater change in temperature than 1 degree in Fahrenheit. All right, so Celsius has a greater value in 1 degree. It takes more degrees of Fahrenheit to equal the same value of Celsius. All right, so we're going to learn these reference points. I know you've done these in previous grades, but it's important that you know them. You should know the freezing point of water in both scales. In Fahrenheit, it's 32 degrees. In Celsius, it's 0. That one's easiest to remember. So you're going to have to work at remembering 32 degrees in Fahrenheit is the freezing temperature of water, but 0 for Celsius. That one's easy. Boiling point of water, Celsius again is the easiest, 100 degrees, but for Fahrenheit, it equates to 212 degrees. And then your normal body temperature, you probably already know the Fahrenheit one because that's the one we use very often here in the US, 98.6. But for Celsius, it's 37 degrees. So you can see how there's a big difference. The higher you go up on the Celsius scale, you go much farther up on the Fahrenheit. There's not much difference between 0 degrees and 32 degrees for freezing temperatures. But when you get into the boiling temperatures, 100 degrees all the way to 212 degrees, great difference. The normal body temperature, 37 degrees all the way up to 98.6 degrees, there's a big difference because it takes more of those Fahrenheit degrees to equal the Celsius ones. So today we're going to work on converting from the Celsius scale to the Fahrenheit scale, and we are going to use this formula. And actually, we're going to start using it without this multiplication symbol, just as a reminder. So to get the Fahrenheit temperature, we take the Celsius temperature and multiply it by 9/5. Yes, it's an improper fraction, so you're going to need to remember because this is going to have to be bigger. The bigger number is going to have to go on the fraction. So 9/5 times the Celsius temperature, and then we're going to add 32 degrees to that. And that's how we're going to convert. So we're going to be working with this formula when we're given a Celsius temperature to convert or to change it to what it would be in Fahrenheit. You are, of course, going to use order of operations. So before we get to that, let's do section 1 where we're filling in the blank. A. You should know it's thermometer. Some of you are probably already looking ahead. Shame on you, you should be listening. B, what do we use mostly in the US? Fahrenheit. Don't misspell it and don't put F. That's being lazy. Write out the word and it's spelled for you right there. C, both temperature scales are based on the boiling and freezing point of water. All right, water's the basis for those. All right, normal body temperature, freezing points and boiling points. Go ahead and fill those in D, E, and F. Section 2 should also be really easy. Okay. Notice we're rounding these temperatures to the nearest whole degree. We've done rounding plenty of times. So if we have something like 23.5 degrees, we're going to, of course, look at the decimal place, and if it's 5 or higher, then we know we need to round it up. It's closest to 24 degrees. If we have 11.19 degrees, that is closest to 11. If we have 5.946, we don't need to pay attention to the other numbers. We just need to look at this and recognize that it rounds up to 6 degrees. So in section 2, they've already done the first one for us. 37.2 degrees Fahrenheit is 37 degrees Fahrenheit. Now notice because they put a measure next to the degrees, they want that in the answer. They show you right there how to do it in example 1. These ones, I didn't give you a degree, but let's say I did. If I said this one was Fahrenheit, I would want this one written in Fahrenheit in the answer. If I said this one was Celsius, I would expect to see Celsius in the answer. The reason for that is if you are given a scale, it's important to put the scale in your answer because it's not going to be the same for both Fahrenheit and Celsius. If you're not given a scale, then you can just round it to the nearest whole degree. Okay? So make sure you've put in the correct ones. You can pause if you haven't finished yet, or you can listen to the answers right now. B should be 13 degrees Celsius. C, we're past that halfway point. Anytime we have fractions and we're past half of the denominator, 3 is more than half of 5. You're going to round up to the next degree, so you should have 30 degrees Celsius. D, 0 degrees Fahrenheit. E, 2 is not more than halfway of 9, so we're going to keep that at 75 degrees Fahrenheit. F, definitely past the halfway point. 7 is greater than half of 9, so we have to round up to 12 degrees Celsius. G, 54 degrees Celsius. H is 3 degrees Celsius. And I is 9 degrees Celsius. So hopefully you did those correctly. Now we're going to move on to section 3, which is actually on the back of your worksheet. So page 268. Notice we're converting from Celsius to Fahrenheit and we're using the formula. Now it's the same thing as this. We just learned that we don't need this symbol and we're practicing not using it. So when I have 9/5 directly next to the C, I still know that I'm multiplying and then I add 32 degrees. So let's go ahead and set up our formula, substituting in that Celsius temperature for C. So F, Fahrenheit, equals 9/5. And you can do this if you want to. You can use parentheses if you want to. We can't stick them together without something there showing multiplication because two numbers don't just go like this. That looks like a crazy, weird mixed number. So we do need to show some form of operation. And then plus 32. Okay. So we're substituting in the temperature for that Celsius. Now I know when I'm multiplying fractions, I'm going to have to make this an improper fraction by putting it over 1 so that I can multiply properly. And of course, always look for cross canceling. I can divide by 5. Let's do this part first before we get to the next step. We're doing order of operations when we're solving. So Fahrenheit, we've got 9 times 3 is 27, which is over 1, so we just have 27. Plus 32, so our Fahrenheit temperature is 59 degrees. So 15 degrees Celsius is the same as 59 degrees Fahrenheit. Let's do another one. Same formula. F equals 9/5 times C. Well, in this case, C is 40 plus 32. Again, order of operations says I need to multiply first, so I'm going to make that a fraction. I can cross cancel. That's going to happen frequently, by the way. Not all the time, but frequently. So let's rewrite to see what we're left with. 9 times 8 is 72, but of course we still have to do the 32. Our temperature is what? Our Fahrenheit temperature is 104 degrees. So as we're going through, we are using that formula, plugging in the value for Celsius, that temperature, in place of C, and then solving to convert. So let's do A and B together, and then I'm going to ask you to pause. We've got 20 degrees Celsius equals Fahrenheit, and then B, we have 65 degrees Celsius equals Fahrenheit. Okay, so we're using this formula. So 20 is going to go in place of C. So 9/5 times 20 plus 32. And if you want to go ahead and make it a fraction when you're writing it, because you know you're going to have to, go ahead and do that. Cross cancel, because we can. 9 times 4 is 36. Plus 32, so we get 68, and don't forget your degree symbol. Thank you, that's driving me nuts. 65 degrees, we're going to plug that into our formula. 9/5 times 65 over 1 plus 32. So again, take care of this first. Cross cancel, because we can divide them both by 5. 65 divided by 5 gets us 13. Now we do 9 times 13, and if you have to write it out, that's fine. Okay. If you don't, great. But we get 117. So if you can multiply that in your head, that's fine. If not, write it out. Figure it out really quickly. It doesn't take very long. 117 plus 32 gets 149 degrees Fahrenheit. Go ahead and do C and D. I will give you those answers when you come back and see if you did them correctly. And then I'm going to let you do E and F on your own, and I'm not going to give you the answers. I'll check them when you turn in your work. So go ahead and pause and do those. All right, so if you came back, let's check. C, you should have gotten 113 degrees. The Fahrenheit's already there, but you should have put in the degree symbol. And then D is 41 degrees. Okay, we always round to the nearest degree, but most of the time in 6th grade, they're going to work out fairly evenly. So make sure you've done E and F. Remember, we're doing all green letters. And then section 4, I want you to solve for x. Some of them are one-step equations, some might be two-step equations, but solve for x, show your steps, and please make sure your work is there. Number 5, you're finding these answers. We've got subtracting and addition with compound measures. C, you really need to be careful with your percentages and converting them to decimals so that you get the correct answer. The numbers or the digits might all be correct, but if that decimal point is in the wrong place, then your answer is completely wrong. So watch out how you change 25.5% to a decimal. All right, D, you're multiplying with compound measures. E, don't forget how we square a fraction. It's not just the numerator. F, you're multiplying, and G, you're dividing, both of those with mixed numbers. Number 6, formulas. Make sure you're using the correct formula. We reviewed circles yesterday. Please pay attention to that for A. B, you're finding perimeter of a square, and C, you're finding area of a triangle. So everything on the worksheet will be done, and you will, of course, take pictures of these and send them to me by Monday. I'll see you in the next lesson. Hope you're having a good day. Bye.